keynote presentation of this session. It is my great pleasure to be the host for this talk. And sadly, recent events made climate action even more urgent. You may know that a heat wave hit the west of the United States and caused cataclysmic melting of the Cascade volcanoes. This happened just a few days ago, and this is something that Dr. Chin and Dr. Xiao can speak to. In particular, Dr. Chin was awarded the Volvo Environment Prize in 2013 for being the lead author of a special report from IPCC on how climate change leads to more extreme weather events. It was the first report to show scientifically what many had already suspected, that extreme weather and climate phenomena have been more frequent over the last 50 years. Dr. Dahe Chin is a geographer, glaciologist, and a climate expert. He is a member of the Chinese Academy of Sciences, a member of the Science for the Developing World, a former director of the China Meteorological Administration. Dr. Chin is also a leader in international organizations and programs, such as the International Polar Year and the Intergovernmental Panel on Climate Change. But Dr. Chin is also an explorer. He took part in scientific expeditions to many cold places. In 1989, he reached the South Pole with the International Cross South Pole Expedition, which was the first crossing of Antarctica with dog sleds and skis. And here you can see, here is Dr. Chin at the South Pole, while this picture shows how the means of transport for getting there. Finally, Dr. Xiao has worked in the fields of polar glaciology and meteorology since 1977. His major research focus has been ice core studies relating to paleoclimate and paleoenvironment, and present-day cold region meteorological and glaciological processes that impact climatic changes. He has gone on observational expeditions in the Himalayas, the Tibetan Plateau at Dome A, the highest point of the Antarctic ice sheet, and at the North Pole, which he reached in an expedition with dog sleds and skis. Dr. Chin was originally scheduled to participate live, while Professor Xiao recorded the talk you are about to hear. But recently, Dr. Chin had to check into the hospital for a health procedure. Dr. Xiao is not present live today because of previous commitments, but he will reply to questions of Rocket Chat. So we are hoping also that Dr. Chin will join the online chat after he leaves the hospital. So I encourage you to go to Rocket Chat and ask your questions that Dr. Xiao will reply in the next few days. And with this, let us turn our attention to the talk that we are all waiting about. And let's give the speakers a virtual round of applause.
On behalf of Professor Qin Dahe, I'm happy to talk about the cryospheric science and its usage of slow machine learning in recent years. So the cryosphere means the Earth's surface with snow and ice, which is very sensitive to climate change. So therefore, my talk will start with a very quick overview of IPCC, which is a climate change assessment results. Dr. Dahe served as a co-chair of RPCC working group one for more than 10 years. So this is basically the outline of my talk. And first, let me show some basic knowledge about the climate change science. RPCC is represents the intergovernmental panel on climate change. When RPCC assess climate change, actually it's not only refers to warm, cold, wet, dry conditions of atmosphere, but refers to all 5 spheres of climate system, which is atmosphere, hydrosphere, lithosphere, cryosphere, and biosphere. And those 5 spheres are interacting each other, leading to the complex climate system. So because of the complexity, so it's very difficult to predict and to project. The ultimate purpose of the assessment is to understand the safe limit of our climate and eventually serve the sustainability of human beings. So the fact that all spheres are changing with overall trends in the past 100 years and especially last decades, that global climate is rapidly warming, such as temperature is rising, sea level is rising, and snow and ice is decreasing and melting. So the evidence of global warming comes from multiple independent climate variables. It's not just come from atmosphere. So now the human itself is a sphere. We call it the anthroposphere, which is now the main driver of climate warming. Why? So this is radiation budget of global atmosphere. It's closed in natural atmosphere, but due to the emission of greenhouse gases of human being, now the budget is no longer closed with additional energy stored in the atmosphere, and it's so-called the greenhouse gases. The traditional numbers are no longer right, so people updated the new number like this. So the big difference is the greenhouse gases installed in the atmosphere and changes the energy of our Earth. So this is all because of the carbon. Actually, the warming is because of the carbon, and this element is that we put into the atmosphere in the last about 100 years since the Industrial Revolution, and especially in the last about 7 decades. It's the most important period. This is a list of the calculated radiation forces of both human-produced and the natural species in the atmosphere. And the red bars indicate the positive radiation forces, so the warming factors. And the left bars are negative forces, cooling factors. You can see that carbon dioxide provides the largest radiation forces. So that carbon dioxide is mainly the cause of the global warming, and this comes from the human activities. This is we can see that there are three levels of radiation forcing since 1950, and increasing from 1915 to 1980 to 2011. So I believe it has increased further till this year, 2021. So the global warming is clear, and the IPCC claims its main conclusion of understanding today. Here is a very short video of IPCC to show that the main conclusion of the IPCC AR5. So actually, IPCC AR5 gave us three key messages of their report. This is a synthesis report released in 2014. The three key messages are: human influence on the climate system is very clear, and the more we disrupt our climate, the more we risk severe, pervasive, and irreversible impacts. We have the means to limit climate change and build a more prosperous, sustainable future. Actually, besides the warming of global mean climate, the worst thing is that there are many climate extreme events today, and scientists believe that we will encounter much more in the future. So this is because of the global is warming, and frequencies of virus with climate extremes will be higher. So that's reasonable because of this PPA figure. You can see we can got more extreme hot days in the right tail of this figure. And this is a big prediction of the hot days in 1.5 and 2 degree warming scenarios in by the end of the 21st century, and their differences. You can see the warmer of the average climate, the more days of hot and extreme hot days. So the distribution almost cover the globe. This year, in North America, people experience the so-called heat dome. So I download some pictures from the internet, and you can see is a hot dome covers the northwest USA and then western Canada. So the scientists believe the most it is the most intense hot days on record. If the global warming continues, and the situation might become very common in the future. Again, here is a short video for the WMO. So they imagine how the weather forecast looks like in summer to the year 2050.
Good morning, and thanks for joining us. I'm Sam Champion, and welcome to the Weather Channel. It's Friday, September 23rd, 2050, and here's a look at today's top stories. Hurricane Kyle is tracking way offshore, but still, Miami's South Beach is underwater. Will this deadly Chicago heat wave ever end, following a brutal summer with record temperatures? Another town dries up as the mega drought in the Southwest continues. And Destination Arctic Circle, why it's becoming the place to go. Let's get started with Hurricane Kyle and storm tracker Jim Cantori in Miami's South Beach. Jim, how? No sign of landfall, but you're standing in water.
Hey, Sam. Yeah, Kyle is about 400 miles offshore, and coastal flood warnings have been issued. Tides running about a foot above where they normally would be, and they're expected to go higher. I mean, a storm that's over 400 miles offshore would never be a problem many decades ago. But now that we have sea level rise, even a storm as far as 400 miles offshore can still cause big problems like you see here. I'm standing in 18 inches of water. The tide is going to come up to about here at its worst point, and then the storm is going to begin to move away, and obviously the tides are going to retreat. Let's take a look at the latest statistics that we have on Kyle for you right now. Winds are at 110 miles an hour. It's currently 400 miles east of downtown Miami. It is moving north at 5 miles per hour. Now, it's these northeast winds that are wrapping around the center that are actually pushing the water back into the Florida coastline. That is our problem. The storm will move out to sea, as you can see here from the track, between the Carolinas and Bermuda. So Kyle's expected to remain offshore and not landfall in the United States. That's the good news, but impacts will remain through the weekend. Sam, back to you.
Thanks, Jim Cantori. Now, as Miami deals with flooding, Chicago is feeling the heat. Ironically, this is the first full day of fall, and this is day 5 of triple-digit temperatures. This late-season heat wave puts us on pace for the hottest September on record. If it verifies, it will be the 3rd warmest September in the past 12 years. So let's take a look at the forecast temperatures for today. At Navy Pier, 96 degrees, just a short walk to Michigan Avenue, and the temperature jumps to 99. Willis Tower will top out at 101, and Wrigley Field, 99 degrees. The heat is a huge factor in tonight's Cubs game against Canada's Alberta Clippers. Edmonton, like many northern cities, is one of the fastest growing right now, due in part to the pleasantly mild fall temperatures in the upper 60s. The Cubbies are playing at night to avoid the hottest part of the day, but even so, temperatures at game time will be in the 90s. The mega drought in Arizona has claimed another casualty. Meteorologist Stephanie Abrams joins us with more.
That's right, Sam. The Southwest has become a tough place to live thanks to a drought that's plagued it for much of the last 50 years. Dinshaw, Arizona is the 4th and largest town to go dry in the last 5 years, and it's only going to get worse. This mega drought is about to claim more cities. Redwall, New Mexico, Rayview, New Mexico, and Cramacos, Texas are now on the list. They're all dangerously close to running out of groundwater, Sam.
Thanks, Stephanie. But if there is a plus, some of those dry lake beds are now being used as solar farms. When we come back, a nearly ice-free Arctic this time of year means a whole lot of new industry for cruising and crude oil. And the winner is Anchorage, Alaska. The 2060 Summer Games are set. More on why it's now the perfect host city.
Climate change is affecting the weather everywhere. It makes it more extreme and disturbs established patterns. That means more disasters, more uncertainty. We can reduce the risks by cutting global greenhouse gas emissions and building low carbon economies. Let's work together to make our societies safer and more resilient. Please join me in taking action on climate change. Thank you.
Okay, thank you. It's a very good imagine of the weather in 13 years later. So now IPCC goes to its sixth cycle of assessment. So it is producing the sixth round reports, and now the IPCC faces several new challenges, such as the SDG, Sustainable Development Goals by 2030 of the United Nations, the Paris Agreement, Sunday framework for the disaster risk reduction, and the new urban issues. So all those challenges are solution oriented. So this is the agenda for the series of reports of AR6. Actually, AR6 have already published 3 special reports. That is a 1.5 degree report, ocean and Cryospheric report, and the land report. And in this August, we will publish the report of first working group 1. I myself is the coordinating leader also of the chapter 9 for working group 1. So we delayed publish the working group 1 report until this August because of the pandemic issue of the last 2 years. And I believe the working group 2 and 3 will also delay their reports. So we already know that there are 5 spheres all changing, and so let's focus to the Cryosphere. And IPCC have give a special report of ocean and Cryosphere on the changing climate. So according to Jim Dahe's suggestion, we will give a very brief and basic knowledge about Cryospheric and the Cryospheric science. So my following talk will be 2 parts. One is Cryospheric definition and the Cryospheric science structure, and then talk about the Cryospheric science in high mountains a little bit. So you can see the Cryospheric components on the Earth. Many people you have seen this in the field. It's a very beautiful view on Earth, but most of them are remote from people. So what's the Cryospheric? So the definition is like this: the Cryospheric collectively describes the elements of the Earth system containing the frozen water. So we define, we categorize these elements or components into 3 parts. A is glaciers, including the ice camp, ice sheet, frozen ground, including permafrost, seasonal foreground, and the snow cover, lake, and river ice. The second part is the sea ice, ice shelf, iceberg, and subsea permafrost. The third one is frozen water in atmosphere, such as snowflakes, ice crystals, ice clouds, and solid precipitation. So these 3 types we have categorized into 3 types. The A is called the continental cryosphere, B is called the marine cryosphere, and C called aerocryosphere. So the cryosphere is an integral part of the Earth system and particularly sensitive to the warming climate. Its state parameters provide an indicator of the change in the climate system through influencing its natural and social aspects. So, for example, the cryosphere influences the surface area and moisture fluxes, clouds, precipitation, hydrology, atmospheric and oceanic circulations. Certainly, it also impacts with human society. So, cryosphere plays a significant role in the global climate system and also the social economic systems. You may know that in the organizers like ICSO and RSSC as a social science, they merged in 3 years ago, 2 years ago, 3 years ago. I can't remember, but that means the nature science and the social science go together to do their solution-oriented problems of our Earth. So that's basically the distribution of the spatial distribution of the cryosphere on Earth. According to the AR5, the glaciers, including the Antarctic ice sheet, Greenland ice sheet, has an ice cap. It covers about 10% of the land area. And the frozen ground, including the seasonal frozen ground and permafrost, covers about respectively 2/3 and 1/4 of the land area. Slow cover covers about 30% of land area in January. And the CI is about 7% of the ocean area. So other cryosphere is important to change this global climate. So there are several aspects. One is the high albedo of the snow and ice compared with other global surface. So you can see that a bit of very pure snow can be 90%. And we can see that the snow cover and ice cover is mainly over the high latitude. And if it changes, that means also change the albedo and therefore change the energy of the Earth's surface. It's also very different if the ocean is ice covered or ice free. I think about the Arctic Ocean. If it's ice covered, and then through the reflection, about 90% of solar light is reflected to the atmosphere. But if it's ice free in the future, about 94% of the energy goes into the ocean, meaning that it will warms the ocean, and this stored heat will eventually come out in the future to heat the atmosphere. And here is another mechanism that means the phase change release large energy between liquid and solid, and also liquid and vapor. Even the temperature of the ice and the water there's no change. They are all 0 degree. Only the phase change they will release or observe 18 calorie per gram for clear and solid phase change. It will be nearly 600 calorie per gram between the liquid and vapor phase change. You can imagine that large area and volume of glacier, ice sheet, permafrost, and snow cover, and sea ice on the Earth. So this phase change will change the energy situation on the Earth's surface. There's a huge organic carbon stored in the permafrost. When climate is warming, carbon will emit to the atmosphere as carbon dioxide or methane as greenhouse gases. So this greenhouse gases in turn will accelerate the global warming. So this is a very positive feedback loop. This permafrost carbon is one of the dangerous conditions that we are facing in the future. And cryosphere also drives the ocean circulation. The meltwater inject into the ocean from North Atlantic and the South Oceans. These cold waters are main drivers of global bottom ocean circulation. They combine with surface ocean circulation. This redistributes the heat between the low and high latitudes, thus make our planet more comfortable to live. And also the cryosphere is a sea level modulator. Certainly ice stored on land or released to the ocean as liquid will change global sea level. Sea level has increased more than 220 meters since the last glacial maximum. It's about 20,000 years ago. Today, with ice sheets and glacier melting, sea level is rising and will rise more in the future. Again, in the future, how much sea level will rise depends on largely how much greenhouse gases we emit to the atmosphere. And of course, the sea level rise partly due to the seawater volume expanding because the seawater also warms because the atmosphere is warm. In regional scales, the shrinkage of the snow and ice changes the local climate, atmosphere circulation, and so the local climate. Also changes the freshwater supply, especially for the dry and semi-arid regions, and also the ecosystem safety. So over the last several decades, global warming has led to the widespread shrinkage of the cryosphere, contributing to the sea level, which is projected to continue in the 21st century and beyond. So you can see from IPCC historical report, this strong trend in this century, and also the long-term commitment. So the further cryosphere is also considered as a good thing to human well-being. We limit the cryosphere services. So following the ecosystem services, we define 4 categories of services, cryosphere services. That is supply services, regulating services, cultural services, and supporting services. Without those services, some people in some regions may meet troubles. So we define a definition of cryosphere services is like this: all benefits human gain from cryosphere system, directly or indirectly, such as resources, products, human well-being, religions. To list all effects of cryosphere, positive or negative, we need to understand its role in the Earth's surface. You can see the cryosphere in this map is interacting with the Far space, thus lead to the benefits or hazard to your human well-being. So to illustrate the structure of the cryosphere science, we draw this schematic tree. The main trunk of the tree, from the root to the top, is respectively the mechanisms, changes, impacts, adaptation, and sustainability. And there are still many gaps to fill to better understand the tree. For example, for mechanism and change, we need to extend the monitoring network and to understand the key processes and the mechanisms. For impacts, we need to understand the interactions between cryosphere and other spheres, and what's their consequences, and also the model improvement. And for the adaptation, we need to focus on its service function and the value of cryosphere change, also the risk assessment and the adaptation and mitigation strategy. There are basically two routes between cryosphere and human well-being. One is the services in the left, and another one is the services in the right. These are two major links between the cryosphere and the social economy. So cryosphere science is actually composed of many branch disciplines, which makes a structured map like this. Some disciplines are very long history, such as glaciology, as you know, it's about more than 100 years. But no, we intended to regard the cryosphere as an integrated sphere. So these disciplines are still useful, but we need to regard the cryosphere as a whole. To set up the whole picture of the cryosphere science in China with the leadership of Dr. Qin Dahe, we compile a series of books on cryosphere sciences, and including the dictionary, glossary, and the outline of the cryosphere science. We are now preparing, and also some books are already published. For example, the climatology, cryogeography, and cryosphere hydrology, cryosphere disaster science, planetary cryoscience, Cryospheric Humanity Society. It's totally 15 volumes will be published this year. So let me go quickly the mountain cryosphere, just to see how many people are living in the mountain regions and how their life influenced by the cryosphere, and it will be a danger if the cryosphere disappear in the future. So this is basically the map of the so-called global water towers, and it is the high mountains of snow and ice. You guys must know very well the polar regions. There are many more people living in the high mountain regions. For example, in the Europe, there's about 2, 3, 4 million people lived in 10 water tower units, or 10 glacier basis. The GDP now is about 6,689 billion US dollar. And for the North America, mostly in North west coast of Alaska and Canada, you can see the influenced population about 19 million people, and GDP about 91.6 billion US dollar, and that's basically 5 water tower units. For the South America, it's basically the Andes, and you can see the population and GDP distribution in the basis. And the total population about 14.6 million, GDP about 454 billion, and the base is 7. There are also some water towers, high mountains of the tropical regions, such as Kilimanjaro in Africa, and Mid America, and also Pacific countries like Indonesia, also high mountains and glaciers. It's not important for freshwater, but it may be important for the tourism. Well, the biggest water tower is Asia. You can see that in Asia, around 10 basis water tower units influence the people about 1,695 million, and GDP about 7,054 billion. And this is the largest water tower in the world. And this Asian water tower influences about 20% of world population, and about 10 major rivers flows into the 3 oceans, especially respectively Pacific Ocean, Indian Ocean, and Arctic Ocean. And people are living in arid and semi-arid area, and they rely largely on the meltwater from mountains, and it's a Cryospheric distributed area, and they're both directly impacted surrounding this cryosphere, and the potential impact exists. You can clearly see that there are lots of benefits from meltwater, and also the disasters happening in this area, in this region. We also call this third pole region. So actually in this region, the water tower can be divided into 2 parts: supply side over the mountain regions, and the demand side of the foothill oasis. So whether the water is balanced or not between supply and demand side determines the healthy condition of the water tower. So whether melting of the cryosphere on the mountains, the supply function is weak, become weak. But with the increased population in the demand side, so the water demand is increasing at the downstream. So there must some conflicts between the supply and the demand. So it's actually it's a risk for the future. So in China, we also concerned about the sea level, because you can see that it's a regional sea level projection for the end of the century. You can see the Asian region is one of the most severe sea level rise region. And China has a long coast of the land, and you can see most developed 3 regions in China is Beijing and the surroundings, Shanghai Delta and Guangzhou Delta. So these three regions will suffer most if sea level continues rise. This is a scenario of the 15 meters sea level rise. So, do you know what's mean of 15 meters? That means the Greenland ice sheet and the West Antarctic ice sheet will gone. And certainly, the two ice sheets gone takes a long time. People believe that it takes several thousand years if this climate scenario and the human activities continues. So Cryospheric was formed actually in 2007 in Perugia in Italy during the IUGG meeting. And but if you trace back to its origin, it goes to 1920s. The International Commission on Snow and Ice. It has a 100 history. And, so because the future Earth and the SDGs, so all science, nature science are facing the sustainable development issues. Actually, in China, we are probably the very first country to name the state key laboratory by Cryospheric science. Actually, we are several months earlier than Perugia meeting. In March of 2007, Dr. Dahe established the laboratory and state key laboratory of Cryospheric science, and he was the first director. And he also planned the structure and the research theme of the laboratory. We talk a lot about the nature and the social economy. The social economy certainly contains culture. So with the loss of ice means that danger to some unique culture of the cold regions. And, we know that many people are living of the Arctic and also the Tibet. So the disappearance of the Cryospheric means that they're hurt to their culture. And sometimes it influences traditional life, and so this it's a disaster to the culture and to the diversity of the human culture of the globe. Here is some interesting picture. And in 2018, we have some accident happening of the Mountain Everest because there are too many people climb the Mountain Everest. Actually, it's a crowd at the peak region. About 14 climbers died because they took road and the people dropped to the rock. And also in China, we are prepared the 2022 Winter Olympic Game. And it's the first time China is host the game. And we are planning this game very well, but we project that after this game will push Chinese people to love this game. And we don't know the situation of pandemic in the next 6 months, but it will come very soon. We're looking forward to this exciting game. So basically, it's the first two parts, and now goes to the third part, emergence of the machine learning on Cryospheric science. Actually, it's the very beginning of this method goes to the Cryospheric science, but just take some example, case studies in this field. So The machine learning is a powerful tool in earth science. This is because of the nature of complex spatial and temporal scales of Earth's surface, and the complicated interactions among spheres and their various components. So Jan Korb summarized the 10 ideas for applying machine learning in earth science. There are pattern identification and clustering, time series and spatial temporal prediction, emulators and surrogates, boundary and driving conditions, interpretability and knowledge discovery, accelerating the inversions, creating high resolution global data sets, uncertainty and quantification, physics-informed neural networks, finding and solving and governing equations. So the x-axis you can see is from more data-driven to more physics-based. The y-axis is from code, not fully mature or require customization to the code nature and readily applicable. So here, my colleague and I just summarized several case studies on cross-science of the machine learning in recent years, and including the data mining on 3 parts, optical CS prediction, permafrost carbon estimation over the Tibet Plateau, payload climate reconstruction, alternate glaciers instability assessment of Greenland. We realize that the machine learning is at the very beginning stage for the cross-field science. They are far from well understood. Anyway, I just show these cases. First is the big mining on the 3 poles. My colleague Li Xin group set up this big data platform for cross-field studies, and it integrates data analysis methods and models into a big data platform. This certainly lays a good foundation for machine learning. We call 3 poles is the Arctic, Antarctic, and the Himalayas, still correct. And the platform contains big data mining method and the high-speed online calculation and the interaction visualization. So you can see this very strong ability to from data to calculation. And for example, people can do slow depth diffusion, slow depth data fusion based on the big data platform. When doing this, they use artificial neural network (ANN) supporting support vector regression as SVR and random forest regression as RFI. That's all the machine learning method. And another example is a navigation information service system for the Arctic Northeast Passage, SNISS. Based on the big data and the calculation and the simulations, this system provides spatial temporal variations of optimal routes for shipping and transit time window and online calculation of routes for safety ship. So far, there are no machine learning on the platform, but I think it is not difficult to do that. The key for the navigation information is actually CS prediction. This can be done using machine learning. For example, my colleague has tried on this field. and the basic idea, simply like this, and Marcus Richardson summarized his idea for CIS prediction using machine learning from knowledge from data and data from knowledge. Certainly, they think that machine learning, deep learning, should be better than machine learning. So there are three methods for CIS prediction: statistical, dynamic model, and machine learning. Since 2008, in earlier June, July, and August, the organizer CIS Outlook SIO, they collect CIS predict results for the upcoming September from all over the world, and they publish their results of CSO as an important platform for the Arctic CIS forecast. So this figure shows that the results of a prediction, the red bars represent the statistical method result. The green bars are from the dynamic models, and the pink bars is machine learning models. Certainly, whatever method, statistical, dynamic, or machine learning, each method has its advantages and disadvantages. So for machine learning, the advantage is very good prediction skills, but the disadvantage is very poor interpretability. The Korean colleagues published a prediction of an Arctic CIS concentration using the full data driving deep neural network in 2017, and they use a monthly mean sea level concentration between 1978 to 2014 for training, and then they predict the monthly CIS concentration of 2015. So they use a root mean square error (RMSE) for the criteria for predict skills. And team, they have predict the monthly Arctic CIS concentration, use the satellite and reanalysis data based on the conventional neural networks, and they believe that the CNN method, the error is about 2.2%. Random forest is 2.35%, and the linear correlation, the traditional one, is 6%. So CNN is the best method. So machine learning is very useful for the CIS predict. So this is the special pattern of the predict skills. You can see that the CNN has the smallest error, and probably the best tool for the predict. So another example is permafrost carbon installation on the Tibetan Plateau. I use statistical and machine learning methods. This is a map of the observations. Actually, they have only 5 domains for the very good observations in the past decades. And there are 2 types of the methods. One is a statistical, 1 and 2, and machine learning, 3 and 4. So they choose totally 9 variables for consider melting factors and frozen factors, solid precipitation, liquid precipitation, potential solar radiation, soil carbon, latitude, longitude, and latitude, So they validate their model using the repeated cross-validation method. So this is the workflow for the predict the soil organic carbon in the permafrost. Although they are very limited observation data, but by machine learning, they can estimate the total carbon storage in the permafrost over the whole over the overall Tibetan plateau. And so by evaluating the model performance, they believe that the random forest model is a better method for estimation. And this you can see it shows a spatial distribution map for the soil organic carbon of the Tibet, and give a very detailed data of the total estimation of carbon stored in the permafrost. And in some regions, the machine learning gives a very high resolution the carbon, and the very high accuracy of the many regions than the traditional old method. And the machine learning also applied to the paleoclimate reconstruction. When my colleague and Yang Xiao did that, and to understand the climate change today and future, people need to understand the climate from the past. However, the traditional method of using proxy like Oscar, tree ring, and lake sediments to reconstruct the past climate, carbon dioxide, and other climate indices remain many uncertainties. So why not try machine learning? It might be a potential approach to dig the proxy to reconstruct the past climate. So my colleague Yang Jiao tried for 3 years history reconstruct in last years. She thought that the application of machine learning method to climate index reconstruction can overcome the shortcomings of traditional linear models, which make it very difficult to portray the nonlinear processes of a climate system, and also effectively avoid the overfitting, which can significantly reduce the uncertainty of the reconstructed processes. And my young colleague Fang Miao also use artificial neural networks proxy system models for training wards and improve the skills of paleoclimate data assimilation. So the pan-Arctic tree rings are used for reconstruct the Arctic temperature pattern of past 1,000 years ago. So along my colleague is Zhang Limin, is now try to use the machine learning to assess the stability of alternate glaciers in all of the Greenland sheets. So there are many processes that impact the stability, but dynamic models are very hard to do that. So he is doing the assessment using the machine learning like this. So his aim is to set up a detection and early warning system to see how this alternate glacier collapse and go fast. But this work is still on the progress and not published yet. Well, machine learning is in cross-site size should not limited to the literal science. It must be also useful to the complex social economy science, such as cross-site services and the regional social economy planning and resilience building and SDG targets. Try to find out the linkages of CrossFit with the SDGs, and it comes out that all 17 SDGs matter to CrossFit impact regions. It's a very simple illustration. And we divide CrossFit services into floors and stokes the both using different color. Those services are then linked to the different categories of the SDGs. So that's so we also try to divide very complicated these linkages between the SDG and the cross services, either directly or indirectly. And you can see use a traditional method. You may judge that those linkages are strong or weak, or it's direct or indirect. But it should be a promising tool using the machine learning to study this problem. And in the future, maybe we do require a big data to study just a very complicated linkages. So this is a conclusive remarks. CrossFit is a sensitive indicator and also strong driver for the global and regional climate change. Because CrossFit is remote from the human main settlement area, the impacts of the change are both direct or indirect. Most through the tele companies, thus lead to the complexity in science. The machine learning is emerging in CrossFit science, showing its promising future. I think it's still far from well explored, so people, especially CrossFit scientists, should engage more in this regard. So finally, we thank that Dr. Wu Tonghua, Yang Jiao, Jiang Limin, Che Tao, and Du Tingfeng for their contribution to this presentation, especially the last part of the presentation. Thank you very much.
Hello. This is the end of the keynote presentation by Dr. Kunde Xiao of Beijing. Dr. Xiao is not present here, as I have mentioned at the beginning. He and Dr. Qin Dahe were not able to be present to answer questions because of emergency situations at their home. However, I encourage everyone who was present or who will listen to this talk in the next few days to return to Rocket Chat. The stream will be live, and your questions will be answered starting on Thursday the 22nd, live by the speaker. So do not lose this thread, and please return to ask more questions. With this, I thank you all. First and foremost, the speakers, Dr. Qin and Dr. Xiao, and then the audience for their interest in this timely and informative presentation. Thank you again.